So let's get started. My name is Jeroen Meulemans, and thanks a lot for joining this session. Looking forward to it. So I'm a solution architect at Databricks. I've been working at Databricks for the last 2 years, mostly in financial services. And before that, I worked at AWS, also mostly with financial services customers. So that's a bit my background. Looking forward to this session. And thanks a lot for spending your valuable time here. I'm still excited about what everything was released this morning. So I'm still trying to process that. So I'm the most excited, I believe, about Unity Catalog being open sourced. And that what that might mean for the standardization of data platforms and the security authorization on top of that. And because there's always a lot of difference between the cloud platforms, especially on authorization language perspective. So today I will be presenting this session to you in collaboration with my colleague Venkat. So I'm sure he will appear soon. So, but I can continue, eh? Yeah, because, okay, great. So, do you have are you mic'd on? Are you mic'd on already? No, I don't. So I think she can help you there. Sure. Is that okay? I'll start with the session. So, the agenda for today is first we'll discuss a couple of customer challenges that we're seeing. Then best practices. Most of those best practices, they are based on the well-architected framework from AWS. So we have all the pillars: security, cost optimization, operational excellence, availability, sustainability. And now it's also been extended with the well-architected lakehouse, which has the pillars of interoperability and openness, and also on data governance. So, I'll do the couple first slide, and then you can pick in. So, basically what we're seeing as challenges at many customers is these three challenges. And the first one is, so if you are a customer for Databricks on AWS, you might be using multiple AWS accounts, you might be using multiple regions, you might have many workspaces, you might have federated teams that are working together. So getting a holistic view on your costs and your DBU consumption or cloud consumption can be very challenging across all these, let's say, heterogeneous environments. So let's say if a group of your users is using an anti-pattern, let's say they are deploying a lot of clusters with low utilization, or they're incurring lots of cost, it's sometimes difficult really to find that holistic view and take corrective actions. So we'll try to help you with that. Then on the second point is the return on data assets is very important. So running a data platform can be costly, but also showing to the business that you are adding value, and also basically reminding them of your value on the next budget cycle can be challenging. So we'll also provide some pointers to help you with that. And last but not least, the governance side. So building this center of excellence centrally within your organization to scale your data and AI capabilities is also key and vital to the scalability and the success of your data and AI use cases. So next is Venkat.
Thank you so much. Can you all hear me? Thank you. So now we are going to talk about the cost optimization, right? So there are three principles that we will be going through today. How to choose the optimal resources. We have, there are set of guidelines and we have a lot of workloads, but still doing the optimal resources is a challenge. And then second is, how do we allocate resources based on the business needs growth? Like, you may need to do scale up, scale out. So you out-allocate resources and then monitoring and control the cost. So those three things we'll be covering. And the very first one is, how do you select, the right compute, right? So generally, the way you will start your workload, you will start with, okay, you think this is the right compute resources, and then you'll keep running, but there is a process we need to do. Like personally, I had an experience where we had to use months and months of engineering exercise to go through what is the optimal compute size. We need to do it. And you do this for every workload. So there are thousands of workloads you will be having, and you need to do this process. It's a time-consuming process. All your engineering effort goes into that, not really working on actual development, right? So this, we have something called AWS Compute Optimizer, the tool that is free of cost. And using the tool, it removes this undifferentiated workload from you and giving you the right option for you to use for your workload. The way it is done, it applies insights from millions of workload. It uses machine learning algorithm, and then it's going to recommend options for you to choose with risk factors, and then you can choose, okay, what is the right one you need to use. So in this example, let's say that there is a general purpose virtual machine for the Databricks workload. This is a MPI 2x large. It is using with the vCPU 8, and instance storage is EBS and up to 10 Gbps. And when you see that monthly cost is 280.32, and after running your compute optimizer, it looks at your activities and finds that you are using only 40% CPU during the day, 10% CPU during the night, and 30% RAM. So you can see that what you had, your configuration, is really like, over capacity. You do not need that. If you have to do this work, it's going to take a lot of engineering, but with compute optimizer, it can do it quickly, and then it's recommending two different options for you. One is, okay, now instead of using 2x large, go with X large, or you can go with R5 large, and one of them has got 50% savings, other one got 67.2%, and with the low risk and medium risk. So if you can do this for every workload. And then now that you're done with the optimizer, you did the right resources. Now the next option is, okay, like, do I need to go for on-demand, or is there any savings plans? As you see the workspace, if it is going to be like you need a committed, like you're going to commit to like 1 or 3 years of hourly usage, then AWS offers something called savings plans. You get up to 72% on the or the savings for 1 or 3 year commitment, right? And in addition to that, we also have Spot. The Spot gives up to 90% discount over on demand. Of course, it is the Spot, it can always taken back, but AWS gives you 2 minutes warning window before taking back, whereas other hyperscalers like Azure GCP, they give only 30 seconds. And then there are 2 types of savings plans that is suitable for There are 2 types of savings plans recommended for Databricks. Compute savings plans and EC2 instance savings plans. The compute savings plans is, it gives you the greatest flexibility. When you say greatest flexibility, you can apply like changing from one region to another region. Let's say you want to go from US East 1 to US East 2 or US West 2, or like you want to go from EU one region to another region. At a global scale, you can change. You can change any instance family. You can change instance sizes, operating system. You can change from EC2 to EC2 Lambda. So it gives all the flexibility, but the discount is 66%. But when it comes to EC2 instance savings plans, you are going to commit to one particular instance family, right? If you're choosing I3, you're going to be specific to I3, and you cannot change regions, and it has to be specific region. So the way Databricks architecture is, you create a Databricks workspace and you assign that workspace to a specific region. And if you think that, okay, if this workspace, I want to maximize my savings plans and I want to commit to this, you can go with EC2 instance savings plans. But if you're going to use other perimeter systems and you want to be more flexible with different regions, then go with compute savings plans, which offers slightly lesser discount. Then the last one from AWS is about leveraging custom-built AWS Graviton 3, which is ARM64-based processor. Databricks built their runtime engine on Graviton 3 instances along with Photon. runtime vectorized Photon engine. With Graviton 3 and Photon, you can see the 3.2x better price performance on Graviton 2 itself, but Graviton 3 offers 25% more over Graviton 2, and Graviton 4 is designed to give you 40% more faster performance, but it is in preview right now in AWS. But that is something like you can experiment, and you can sign up for Graviton 4. The link is provided over there. And with that, I would like to give it to Jerome. Like, he's going to talk about how Databricks is going to give some of the cost offerings, cost savings techniques.
Okay, thank you very much, Venkat. Yeah, so let's continue. So it might be an open door, of course, at the Databricks conference, but I also think that Ali was emphasizing that this morning. So don't give your data to vendors; they will lock it away for you. So make sure you choose open formats and also open solutions such as Delta and Unity Catalog since today. So here we see an example of a customer choosing Delta to use on the data lake, and he's seeing impressive cost savings, both from a data volume perspective as also from a compute perspective. So in this case, they see 87% compression of their files, which reduces in reduced compute cost and improved query times. So Delta is the foundation for both the bronze, silver, and gold layer for your data lake, and has lots of advantages. So if we continue this path, so how can we reduce the I/O to the cloud storage, to S3? Because we want to reduce cost, we want to improve our query time. And let's say the standard Hive-style manual partitioning is really good for use cases where you have high cardinality, and you can really make a nice separation or segregation into a specific attribute. But of course, it requires manual tuning. It requires you to rewrite tables upon ingestion of new data. And that's why basically Databricks also added a new innovation in Delta 2.3, which got open sourced, called Z-ordering. And Z-ordering really helps you with collocating relevant information. So if you have more, like, let's say, complex queries with range statements or multiple select fields, then Z-ordering will automatically basically collocate that data in those Parquet files, which will improve your query time by a lot. My personal experience with financial services customers that are using Z-ordering is that they were able to reduce their cost by 66% over time of their ETL pipelines. So overnight, a reduction of 2/3 of the cost and a query improvement time of a factor 6. So I've been really impressed by Z-ordering. And recently, there's basically a next generation of data skipping algorithms released by Databricks as well, called liquid clustering. It has nothing to do with clustering itself, like shared clusters or compute, but liquid clustering is basically automating the whole partitioning for our customers. It also allows you to change keys that you basically want to sort on over time. And it also allows you to ingest new data over time without actually having to rewrite your tables. So I would definitely investigate liquid clustering, as it promises to even improve performance on top of Z-ordering. So then we've already discussed, Venkat, also the difference between the on-demand and the spot instances. So Databricks and AWS definitely recommend to use a hybrid approach. So basically you run both on-demand instances and spot instances for your workload. As a solution architect, I would ask my customers, okay, what is your SLA? And what is your possibility to withstand faults if spot instances would shut down? The driver node is always recommended to run on demand because basically it allows to be fault tolerant and to restart certain tasks and queries. But on the worker nodes, we advise you to adopt a hybrid approach. And spot instances can really save up to 90% of EC2 costs. So it's a really big step. There are also some AWS tooling that allows you to see the likelihood of a certain instance types to be stopped in a specific region. So also do investigate that when adopting spot instances. So other functionality that will allow you to optimize the utilization of your infrastructure is called autoscaling. So autoscaling works really well together with DLT, so with Delta Live Table. It's called enhanced autoscaling. So the control system is using system utilization to basically shut down unused capacity, or basically start capacity that is required for the pipelines. So this will also help you with improving utilization of your architecture. So also, as what Ali said this morning as well, so you are paying for idle time if you use classic infrastructure. So move your use cases to serverless infrastructure. More and more use cases are available on serverless infrastructure. My personal use case that is preferred for serverless is, let's say, BI reporting. So let's say we're from 9 to 5, we are seeing very spiky behavior from our BI users. And they want to have a great user experience. They don't want to wait 5 to 6 minutes before new compute is started, but they want to have like instance new compute available. So the serverless DB SQL solution starts up in about 7 seconds. And also the auto-terminate functionality is very crucial, because if there are no queries hitting the endpoints, then you also want to shut down the serverless infrastructure, because you don't want to be paying for idle compute. And serverless will really help you here. So on the GenAI, of course, side, everything is in full swing. We've heard this morning as well that it's very energy consuming. That also means it can incur high charges. So how can we make sure that we control our GenAI inference costs? Because a large part of our costs will be the inference costs. So let's say if we build a GenAI architecture or application, then there are some factors that really weigh into the cost. First is, of course, the internal success of your application, the amount of users that are going to be hitting your application. Second is how many tokens are required per query that my user is sending in the application. Then a third one is, of course, how many queries is a user going to send before getting a successful answer. Right? It could be, it's an iterative process, the prompt engineering, so it could be 2, 5, 6 times before the user is really getting an answer which he or she is satisfied with. And of course, the performance side. We see a lot of closed and open models now with mixtures of experts or more, let's say, dense models. And we see a lot of performance. Like a GPT request can take maybe 5, 6, 7 seconds before you get a response on the API call. And DBRX could maybe do that in, let's say, less than a second. So it's also very important to choose the right model for your use case, and also basically look at the performance side as it will impact user experience and cost. So Databricks today has both a pay-per-token consumption model as a provisioned throughput. So we recommend today for production applications to use the provisioned throughput Mosaic ML LLM foundational model serving. And the nice thing about it as well, they have a feature, it has a feature called scale to 0. So imagine if you start up your generative AI endpoints on a Friday afternoon and you forget to shut them down before going into the weekend. You don't want to be left with a huge bill on Monday morning. So scale to 0 will automatically shut down these endpoints if they're not used. So it will really reduce for you the risk that there will be any anomalies or that there are costs that will not be within control. And yeah, the nice thing also here is there's no upfront reservation required when using provisioned capacity with Mosaic ML today. So then one of my favorite functionalities that have been added as part of Unity Catalog is the system tables. So the system tables gives you basically a programmatic interface to get full observability of your data platform. So the system tables, they have, let's say, access in a programmatic manner to the lineage, to the auditing capabilities, but also performance-wise, system utilization. We've recently added new system tables called system.workflows. They're in public preview as of today. And system.workflows allows you to query programmatically how your jobs are running and also who is running those jobs, also the tasks they are running. So that's very recent information just as of today. And they can be used for billing, of course. So that's why it's part of this presentation. We have some off-the-shelf billing capabilities. So within Lakehouse dashboards now, there is a standard template. So it doesn't require you to do any coding to get really nice information. Okay, what kind of consumption am I seeing on my data platform? Who are my heaviest consumers? What workspaces are using the most DBUs? But you can also make a bespoke or customized solution yourself. So you could basically write your own reports using, let's say, external tooling like Power BI or Lakeview dashboards, whatever BI tool you prefer. And you could basically also build your own applications that integrate AWS billing information on EC2 and other services with the system tables. So basically, we have all kinds of options from off-the-shelf without any coding requirements, to really very much bespoke solutions that are customized to the enterprise you are working in, and that you can really like follow the domains and basically the organizational complexity of your own organization. So one of the examples you can see here, this is a system table. So a system table is basically a catalog of Unity catalog with many schemas in the system table, and per schema it gives you a certain kind of observability. It could be lineage, it could be auditing, it could be access control, it could be billing. And in this case, we see the usage the usage table of the billing schema. And as you can see here, we have lots of attributes that we can use to build our queries. And as you can see, the SLA that we commit to our customers today is basically P99 1 hour. So it basically means that all your Databricks consumption will be available to query within 1 hour on the system table catalog. And so one of the nice demos that I would like to show, but we don't have really time today for that, is the dbdemos.ai website. So this is a pre-made dashboard of DBU consumption using system tables. So here we are using the notebook capability. All these notebooks are available free of charge. You can just download them and build your own reports. And the capability that has been built here on top is, you see the black bar, vertical bar, that's today. So on the left, we have all kind of historical reporting, but we're also using the profit forecasting library from Facebook to do budgeting and do forecasting of our budget in the future. So with a very simple notebook, we can do historical reporting, but also budgeting for the future. And then some capabilities that have been recently added to the portfolio as of this week. So we had to change the slides very last minute as well. One of them is called budget alerts. So more and more, like let's say data scientists, they want to have the autonomy to deploy their own services, but we also don't want to make life too hard for them and only create preventative controls. So this is a detective control, and part of Databricks, off the shelf, here you can see a budget alert. So we are seeing now, you can see all kinds of projects defined, and a project can be based on tags. It can be a grouping of a number of workspaces. And basically you can trigger alerts if you go over a certain threshold. So this capability is in public preview and only available on AWS as of today. Another capability that has been added, I already mentioned. So if you want to run reports on top of system tables, we have off-the-shelf capabilities and bespoke capabilities. So this is the off-the-shelf capability that has been made available very recently. So by just using Lakeview dashboards, you can query those system tables without having to write any, let's say, SQL. And on the right side, you see all the categories of Databricks products that you're consuming, from model inference to Delta Live Table ETL pipelines to DB SQL warehousing. So you can really see, okay, what are basically my main costs of the platform, and set up all kinds of detective controls to maybe even, let's say, name and shame users if they go over a certain budget, so that they can basically also take corrective patterns, corrective actions, and change their behavior as well on the platform. So this is really also very recently added to the platform. So thanks a lot. So Venkat will now do the closing words.
So can you hear? Yeah. Yeah. So you saw like what AWS and Databricks provides the way to save costs, right? But cost management is a discipline. Like, it is not just using tools and technologies. There are 4 steps that AWS recommends. Like C means every department, like everybody, like finance department or IT or HR, like different business unit, they should be able to see how the money is spent, right? So there is a approach called tagging. You can use tagging for each resource. You can have multiple tagging. That is a way, like, you can organize and you can report at every level, and you can decide whether you are spending your money wisely, right? And then the second is saving costs. Saving costs, we already talked about the various ways, and one of the ways to do using AWS Cost Optimizer, that's going to give you the recommendation, and you can save costs, and plus you can also apply other techniques that's been given. Planning and forecasting, it is a continuous journey. It's a continuous process. You need to keep doing this at a frequency where every quarter or every 6 months, you want to run this automation and see if the cost, what you're seeing, it makes sense, and you adjust, you improve your process. Then finally, it's billing, like running. That's where like automation comes into picture. You want to minimize manual workload, so automation is going to help you do. It's a flywheel approach. You keep doing it, you're going to see efficient process. That's it.
Great, thank you very much. Thanks a lot for your time.